Hello my dear students, welcome back to Learn Physics. Today we are starting a new chapter, that is Magnetism and Matter. In today's video, I will be explaining about reduced syllabus of this chapter and some introductory part. So in previous years and all, we have lot of things to study in this chapter. But this year, due to pandemic, they reduced the syllabus. So the syllabus includes only this much. That is current loop as a magnetic dipole and its magnetic dipole moment. Then magnetic dipole moment of a revolving electron. Bohr magnetron and all we will be learning over there. Bar magnet as an equivalent solenoid. Magnetic field lines. Earth's magnetic field and magnetic elements. These are the topics to be covered in this chapter. And when it about the torque, paramagnetism, diamagnetism, ferromagnetic substances, electromagnets, all those things, it's removed from this syllabus for this year. Okay, only for this year, that I'll wait and see. Okay, so in this video I'm going to give an introductory part of this magnetism, some basics of magnetism. Okay, the first one is as we all know, the earth will behave as a magnet. Earth is behaving as a magnet because it is having north pole and south pole, and earth has magnetic properties. Okay, then the next one, every magnet will be attracting small pieces of magnetic substances towards it. Example, iron. Magnet will be attracting iron, cobalt, nickel and steel. Such kind of small magnetic substances will be attracted towards the magnet. Okay, so if these substances are not having magnetic property also, it will be attracting. Okay, so which is attracting towards the center, towards the magnet. So the magnet will be having the ends, right? The ends of the magnets are called as poles of a magnet. Poles means ends of the magnet. The magnetic poles will always exist in pairs. Pairs mean two. So magnetic poles won't exist in single. Magnetic monopoles won't exist. It is having a north pole and a south pole. So it will always be existing as north and south together only. Only north pole or only south pole won't be there. If we are dividing this into two pieces also, see, this side will become north and the other side will become south. And then the other part also, this side will become north and this side is south. Like that only it will be existing. Then next is, when a magnet is suspended freely, it will come to rest in north-south direction. That's why the north pole is, if we are suspending the magnet with a thread, it will be in the north-south direction of Earth. Earth's north-south direction, it will be it's resting in that position. Okay, one will be pointing towards north. If the point which is turning to that north side of Earth, that is called as north seeking pole. Actually, the north pole which we are marking over here is a north seeking pole. South pole which we are marking is called a south seeking pole. See, here you can see the north-south of a bar magnet is suspended with a thread, and here it is turning into north side of the earth and south side will be turning to south side of the earth. So this north is called as north seeking pole and this south is south seeking pole. Next is, like poles repel each other and unlike poles attract each other. Like poles means north and north or south and south will repel, but north and south will attract each other. See, here you can see north and north will repel, south and south will repel, north and south will attract. The force of attraction, next point, what will be the force of attraction or repulsion between the two magnetic poles of strength M1 and M2? If these are separated by a distance r, then what will be the magnetic force of attraction? Force of attraction between the two poles. Okay, suppose if I am considering a magnet which is, see, same magnet, if I am one single magnet I am considering, means it will be having one north pole and south pole. The magnetic moments are m1 and m2, both will be same here, which is separated by the distance r. If I am considering these two magnets, okay, if I am considering these two magnets, it will be this will be having one magnetic strength and the other one will be having another can be. It's always it won't be always like same poles, same strength magnet only will be coming next to each other. It's not like that. Maybe one will be stronger and the other will be weaker. That also can happen, right? So here, if they are separated by a distance r, and one side is m1 and the other side the strength is m2. So m1 and m2 are the strength of the two poles of two magnets, and which is separated by the distance r. Then what will be the force of attraction or force of repulsion? That will be directly proportional to the product of their masses, m1 and m2. So it is directly proportional to the product of masses and inversely proportional to the square of distance between their centers. So F is proportional to m1 m2 by r square. What is this m1 and m2? Magnetic pole strength. M1 and M2 are the magnetic pole strengths. R is the distance between the poles of a magnet. So here to change this proportionality sign, we can multiply it with a constant, that is mu 0 by 4 pi into M1 M2 by R square. What is this mu 0? That is magnetic permeability of free space. Mu 0 is the magnetic permeability of free space. Its value will be 4 pi into 10 to the power minus 7. 4 pi into 10 to the power minus 7. So how we can define the strength of a magnet or magnetic pole strength? How we can define that? Usually for defining a particular quantity, what we will be doing, we will be taking the equation and substituting everything as 1 and will be finding out. Same way here also, strength of magnetic pole. How we can find out? See, now we know the equation F is equal to mu 0 by 4 pi m1 m2 by r square. In this, if I am taking m1 is equal to m2 equals m, that is 1 ampere meter. The unit of strength of magnet is ampere meter and it is separated by a distance of 1 meter. Then what will be the force? Here it is m divided by this m is 1 each and r is 1. So we will be getting mu 0 by 4 pi. Mu 0, what is the value of mu 0? 4 pi into 10 to the power minus 7. So 4 pi will get cancelled. We will get it as 10 to the power minus 7 Newton. So if we are making this as a sentence, you will be getting the definition for strength of magnetic pole. Strength of magnetic pole is said to be 1 ampere meter if it repels an equal and similar pole when placed in vacuum at a distance of 1 meter from it with a force of 10 to the power minus 7 Newton. Okay, it's giving a 10 to the power minus 7 Newton if the magnetic pole strength is 1 ampere meter which is separated by a distance of 1 meter. So the next is magnetic field lines. What is meant by magnetic field lines? If I am considering a magnet, whether this magnetic field lines are existing over there? No, it's an imaginary line. So it's an imaginary line which is drawing from the north to south pole of a magnet. Okay, it will be drawing from north to south pole, or we can say it will be the path of the compass needle. If I'm taking a compass needle, the compass needle will be having a magnet inside, as a magnetic needle inside that. So how the magnetic needle is moving? The movement of the magnetic needle can be traced out, and when we are tracing out that, we will get the magnetic field lines. So it's an imaginary curve. So if I am drawing tangent for that curves, we will be getting the direction of magnetic field. Okay, the path along which the compass needle are aligned is known as magnetic field lines. Now you can see here, this is in magnetic field lines. In the case of a bar magnet, it will be moving from north to south pole. It will be moving from north to south pole. When it is moving like that, if I want to find out the direction of magnetic field line or magnetic field, I can draw a tangent like this. Okay, if I am drawing a tangent here, we will be getting a tangent if I am drawing like this, and if I want to know the magnetic field line here, I can draw the tangent here. Okay, so here it is showing the Earth's magnetic field also is showing over here. Okay, from north to south pole it is showing here. Okay, then this will be the magnetic field lines, and the tangent to it will be giving the will be giving the direction of magnetic field. And we know it won't be intersecting each other. Magnetic field lines will never intersect each other. If it intersect, what will happen? That point will be having two directions because it is intersecting. Either, see, if one line is like this, if I am drawing one more line in this manner, so at the point where the intersection is happening, it can go in this direction or in this direction where I am giving the line, right? So in both the direction it can be. So for a single point, whether two directions are possible? No, right? So it will never intersect. And this magnetic field lines will be helping to find out the strength of magnet. See how if I am taking a unit area over here, and here also same unit area I am considering. Here also I am considering the same unit area. In different positions I am considering same unit area. Which one has more, which area includes more number of magnetic field lines, that will be representing the stronger magnet. Okay, so if the area included contains more number of magnetic field lines, that will show the number of strength of magnet. Okay, so now we are concluding all the properties here. Magnetic field lines of a magnet are formed closed continuous loops, and outside the magnet, outside the body of a magnet, the direction of magnetic field lines from north to south pole. Direction will be from north to south pole outside, but inside it will be from south to north pole. That is how it will become a closed curve. At any given point, the tangent to the magnetic field lines represents the direction of magnetic field. And the magnitude of magnetic field lines at any point is represented by the number of magnetic field lines passing normally through a unit area around that. So magnitude is represented by the number of magnetic field lines in unit area. And one more point, they never intersect each other. No two magnetic field lines can intersect each other. That is, magnetic field lines won't intersect each other. Clear, children? So that's all. So in the next video, I will be coming with the rest of the topics. So it's clear for you, I guess. And if you like the channel, please don't forget to subscribe, like and share. Thank you.